scraps fell out of a trash bag. Crows felt like background noise, like something the city forgot to clean up. I never gave them a second thought. Then I heard about a little girl in Seattle who started leaving gifts for a crow. She'd put out food every morning, and the crow kept coming back. That wasn't unusual. But then, slowly, the crow started leaving things for her. A shiny button, a small piece of glass, a paperclip, a tiny screw. Over months, the pile of objects grew. The crow wasn't just returning for food, it was reciprocating. Everything I thought I knew about birds collapsed. Because here's the thing nobody tells you about crows. They're not just smart for a bird. They're smart in ways that overlap directly with humans. They plan for the future. They hold grudges. They recognize faces, remember them for years, and pass that information to their children. Some researchers now believe crows may have a form of consciousness ever attributed to mammals. A black bird on a wire. I was completely, embarrassingly wrong about what I was looking at. Crows belong to a family called corvids, which includes ravens, jays, jackdaws, and magpies, and this family sits at the very top of the avian intelligence pyramid. But even within corvids, crows are special. They've developed cognitive abilities so advanced, so unexpected in a creature with a brain the size of a walnut, that they've genuinely forced scientists to rethink how intelligence works. To understand why crows got this way, you have to understand the world they evolved in. Unlike most birds, crows are generalists. They don't specialize in one food source, one habitat, one strategy. They live in forests, cities, deserts, Arctic tundra, and coastlines. They eat fruit, insects, carrion, eggs, small animals, and human garbage. This extreme adaptability sounds like a survival advantage, and it is, but it comes with a brutal cost. When your environment is constantly changing and unpredictable, instinct isn't enough. Instinct is just a set of fixed answers to fixed problems. Crows face problems that have never existed before. And to solve new problems, you need something beyond instinct. You need a mind that can improvise, and over millions of years, that's exactly what crows developed. A brain structure so efficient, so densely packed with neurons, that it punches far above its weight. The crow brain is not built like a mammal's. There's no neocortex, the folded outer layer we associate with higher thinking in humans and primates. For decades, scientists assumed that meant birds were cognitively limited, that the neocortex was the seat of intelligence, and without it, complex thought wasn't possible. That assumption turned out to be completely wrong. Crows developed a different region of the brain called the pallium, which performs many of the same functions as the neocortex, just through a different architecture. It's the same destination reached by a completely different road, and recent neuroscience has shown that the crow pallium is packed with neurons at a density that rivals primates. A crow has 0.5 billion neurons, a macaque monkey has around 6 billion. But the crow's brain is also 60 times smaller. Neuron for neuron, adjusted for size, crows are operating at primate level. Sometimes, beyond it. And the behaviors that produces are genuinely shocking. Let's start with tools, because this is where crows first broke the scientific consensus. For a long time, tool use was considered uniquely human. Then we found it in chimpanzees. Then in dolphins, elephants, some birds. But crow tool use isn't just using a stick to poke at something. It's designing tools from scratch for a specific purpose they haven't encountered yet. New Caledonian crows, a species from the Pacific Islands, have been studied intensively for decades. In laboratory experiments, researchers presented them with a problem: food placed at the bottom of a narrow tube, unreachable by beak or claw. Nearby were several wire lengths, none of which were the right size or shape. One crow, famously named Betty, spontaneously bent a straight wire into a hook and used it to retrieve the food on her first attempt. She had never seen wire before. She had never been trained. She assessed the problem, understood what shape she needed, and manufactured it. That's not instinct, that's reasoning. But what makes New Caledonian crows even more remarkable is what happens in the wild. They craft tools from pandanus leaves, trimming the edges to create barbed hooks for extracting insects from bark. They do this consistently, with recognizable design standards that are actually passed down across generations. It's not just tool use, it's tool culture, a technology inherited through social learning, not genetics. When I first read that, I had to stop, because that's the foundation of human civilization. Inherited technique, accumulated knowledge, the ability to learn from predecessors, rather than reinventing everything from scratch. Crows have been doing this quietly in Pacific Island forests for thousands of years. But tool use, as extraordinary as it is, isn't what truly sets crows apart. What sets them apart is their relationship with time. Most animals live almost entirely in the present. They respond to immediate hunger, immediate threat, immediate opportunity. The ability to mentally project yourself into the future, to plan for a situation that doesn't exist yet, was long considered a uniquely human trait. Scientists called it mental time travel, and they assumed it required a level of self-awareness that other animals simply didn't have. Then, they studied crows. Western scrub jays, a corvid closely crows, were given food in the evenings and allowed to cache it wherever they chose. Then researchers manipulated the experiment. Some jays were given abundant food in the morning, others were given nothing. What happened next was extraordinary. The jays experienced hungry mornings, began caching more food specifically in the location where they expected to be hungry the next day. They weren't just storing food randomly. They were planning for a future emotional state they hadn't experienced yet. They were thinking about tomorrow. And crow planning doesn't stop there. Crows also appear to understand what other crows are thinking, which is something called theory of mind, and until recently it was assumed to be almost exclusively human. Here's how researchers discovered this. When crows cache food, they're intensely aware of who's watching. If another crow observes them hiding food, the caching crow will wait until the observer leaves, then move the food to a new. But here's the detail that changes everything. They only do this if they have previously stolen food from another crow themselves. Crows that have never stolen don't bother recaching. Only the thieves assume they're being watched by other thieves, because they know from their own experience what a thieving crow is capable of. They are attributing their own mental states to others. They are modeling another individual's intentions based on their own past behavior. That is theory of mind. In a bird. Then there's the part that I find the most unsettling, in the best possible way. The part about faces. Crows recognize individual human faces. Not hats, not clothing, not body size, faces. And they remember them. For years. A now famous study at the University of Washington confirmed this precisely. Researchers wore specific masks while trapping and banding crows. After release, those same masked researchers were scolded, dive-bombed, and harassed by the crows every time they appeared on campus. Researchers wearing different masks were ignored completely. The crows knew exactly who had wronged them. Over time, the number of crows that scolded the threatening mask actually increased, even though those birds had never been trapped. They had been informed by other crows. The knowledge of a dangerous human face spread through the crow population socially, passed on through alarm calls and observer. Parents were telling their children. Crows who had never seen the mask learned fear it, because the community remembered. This is social transmission of specific knowledge about specific individuals. It's closer to gossip than instinct. And if crows can remember enemies, they can also recognize allies. People who regularly feed crows often report being followed on walks, having crows land near them, receiving objects left on windowsills. The gift-giving behavior isn't random. It clusters around individuals who have built trust with a local crow community over time. The crows are maintaining relationships, long-term, reciprocal, socially complex relationships with members of a completely different species. Which brings us to something researchers are still arguing about. The question of whether crows are conscious. Is a loaded word. For our purposes, let's define it simply as the ability to have a subjective experience. To be aware not just of the world, but of yourself existing within it. For decades, a test called the mirror test was used as a rough indicator of self-awareness. The idea was simple. Put a mark on an animal where they can't see it directly, show them a mirror, and see if they try to remove the mark. Chimpanzees pass this test. Elephants pass it. Dolphins pass it. Most animals don't. Magpies, another corvid, pass it too, making them the only non-mammal ever recorded to do so. But some researchers think the mirror test is the wrong question, because in 2020, a study published in Science found something far more provocative. Crows have neurons in their pallium that fire in response not just to external stimuli, but to internal states. Neurons that seem to represent the crow's own awareness of what it's perceiving. When a crow saw a stimulus and was asked to report whether it saw it or not, certain neurons activated that corresponded to the crow's subjective experience of seeing, independent of whether the stimulus was actually there. This is the closest thing we've ever measured, in any non-human animal, to a neural signature. But they said the data was consistent with a primitive form of sensory consciousness, a felt experience of the world, not just processing input and generating output, but actually experiencing something. A crow sitting on a wire might be experiencing that wire. Experiencing the cold air, the view, the particular quality of that moment. Not just registering it, experiencing it. I find that genuinely hard to process. None of this emerged by accident. Crows evolved these capabilities because their environment demanded it. A life spent navigating complex social groups, unpredictable food sources, territorial disputes, and predator-rich environments selects hard for cognitive flexibility. Every generation, the crows that could remember more, plan better, read social situations more accurately, survived and passed those tendencies on. Intelligence in crows didn't come from safety. It came from pressure.